Hello and welcome to D's ADD videos. We're going to do an example of relative extrema with multiple variables using these steps here. If you remember from the concept video, we're going to have to take the partials, set them equal to 0. You'll get two equations with two unknowns, solve the system of equations, set up this general D formula, and then evaluate it at each critical point. And if it's less than 0, it's a saddle point. Greater than 0, you go to fxx and evaluate that. And if it's equal to 0, it's inconclusive. Alright, so fxx, it was opposite what logic would dictate. You would think greater is a max, but it's actually a min. You would think less than is a min, but it's actually a max. So looking at this problem here, let's see what happens. So the derivative with respect to x, pretty straightforward partial derivative. If that does not make sense to you, go back and watch a partial derivative video. Derivative with respect to y would be a equation that looks like that. Set them both equal to 0. That's this was step 1. Here's step 2. Now we solve them, right? What I'm going to do is I'm going to solve for y in this equation and plug it into that equation. Let's see how that works out. So I have 3x squared minus 3y equals 0. Add that 3y over. Oops. One too many y's there. And then divide both sides by 3. And then cancel, and you get y equals x squared. Well, if y equals x squared, I can plug that in right there. So, doing that, we get a negative 3x minus 3 parentheses, and I'll put this in a different color because it'll indicate that that's the thing I plugged in. Alright, so that's still equal to 0. Now let's solve the system of equations that result. So I can factor out well, actually, let's not skip any steps. Be good math students. You also get more opportunities for partial credit if your professor is nice enough or grader is nice enough to give you partial credit. Now we see that there's a negative 3x common to both of those. If you factor that out, you get 1 plus x cubed. Setting each one of those equal to 0, you're going to get a negative 3x equals 0, x equals 0, and then I'm just going to rewrite it as x cubed plus 1. If you remember, x cubed plus, or actually let me just do a general formula here. Let's use green. A cubed plus y cubed, or b cubed. If we're doing a factoring, you're going to get a plus b times a squared minus ab plus b squared. Okay. So of these two, only the first expression is going to have a solution, a real solution. This one never has a real solution. Alright, so you can just say, okay, it's just going to be x plus 1 equal to 0 and get x equals negative 1. But since I'm being a good math tutor, I'll just show you what it factors into. It's a square right there. And then if you set both of those equal to 0, only this one has a solution of negative 1. Alright, so we've got two x values. Now we need to find their corresponding y values. Well, how about we go to where it says y equals. Anytime you're looking for what y equals, look for something that you've done in your work already that says y equals this, and then just plug it into that. It's a lot less work. Some people go back to these equations up here, and though it's not that much more difficult, you just want to be efficient and do things as best as possible. So y of 0 equals 0 squared, which is 0. Alright. And then that tells us our first critical point from that is going to be 0, 0. Then if we did y of -1, running out of space, let's create some more. Y of -1 would be -1 squared, which is 1, so that point is -1, 1. So now we have to set up our D formula. In order to do our D formula, we need to do the second order partials. So f of x says go to the x equation, derive with respect to x. Make sure I got room there. So this is the x equation with respect to x. That would be a 6x. F of y would be a -6y. And then your mixed order partials should equal each other. So xy would be a -3 and yx would be a -3. Alright. If you guys forgot, just a quick refresher. The first subscript tells you the equation to go to. So this says go to fx and then derive this with respect to y. This one tells you what to derive. Alright? And indeed they do equal each other, so let's set up the D formula. D of AB would equal f of x, AB, f of y, AB, minus f of x, y, or yx, it doesn't matter, they're the same value, squared. So we have 6x, -6x, and then a -3 squared. There's your general D formula. Let's clean it up a little bit. It's going to be a -36. Oop, this should have been a y. One of them should have been a y. Which one is a y? FYY. -36xy minus 9. There's your general D formula. So now we're going to have to apply that for D of the first critical point, which was 0, 0 from our work earlier. -36 minus 9. Plug in a 0 and 0 there. That's what the f of xxab means. Plug in that critical point there. And that's going to give you a value of -9, which is less than 0. Therefore, 0, 0 is a saddle point. Okay. Then if you did D of 1, -1, 1. It's a -1, 1. Yeah, just rewrite that. -1, 1. You would get a -36 times the two critical points. So the x value is -1, y value is 1. So when you evaluate that, you get 36 minus 9. Doesn't matter what the value is. What's that, 27, which is greater than 0, but all that matters is that it's greater than 0, so we go to fxx, which was 6x. And we evaluate fxx at AB. In this case, our AB, let's go ahead and write them in, are -1, 1. So it's 6 times a -1. Which that's a -6, which is less than 0, and you would think less than is a min, but it's actually a relative named Max from Ohio. Yeah, that's a bad joke, I know. But alright, so just make sure you are careful. This concept's not too bad. You just got to practice a few of them, and you should be fine. Okay, so set the. Usually, what I do is I just take all the partials, and then after you do that, then you're gonna end up solving the system of equations, a little algebra there, and then finding your critical points, and then after that, evaluating your critical points. I hope that has clarified things. Make sure you practice, practice, practice. Thank you, and have a nice day.